Evening class, welcome to our presentation on revision for COS3711. We'll be going over the June-July 2021 past paper this evening. Before we get going with that, just some updates. The next class will be next week, same time, next Wednesday. And we'll be going through the October-November 2021 past paper. A week after that, Dr. Pilkington will be doing a presentation on, I think it's the May-June paper from this year, which was a revision paper. I mean, not a revision, was a sub-paper. Only 2 or 3 students actually wrote the paper, but anyway, he'll be going through that one. And if you have any queries about the exam procedure and anything, I suggest you join that meeting and ask Dr. Pilkington. He should be able to answer any queries that you may have. Then the other thing, earlier this afternoon, I've sent out an email about an e-tutor evaluation survey. Hopefully you'll get it sometime fairly soon. I'd ask you to spend a few minutes, please, to respond to that survey. The survey is being done by Unisa admin. So neither Dr. Pilkington or myself have any idea what's in there. I have no access to it. So please spend a few minutes and respond to that survey when you get it. There is unfortunately a problem with emails being sent out by my Unisa at the moment. There's a bit of a backlog, so I don't know when it will get out. If it doesn't go out in the next day or so, I'll put an announcement in my Unisa. Please, when you log in, just spend a few minutes to fill in the survey. Other than that, let's get going. Can somebody just confirm that you can see my screen? I've got no idea what you can see.
Yeah, we can see your screen.
Okay, excellent. Right, let's get going. Right, just before we get to the paper, I'm just going to go through some general stuff about the exam that you need to know and be aware of. Firstly, just to confirm the syllabus, which obviously you should all know about. Pretty much everything is based on the prescribed book, An Introduction to Design Patterns in C++, or the second edition, or easiest as it's known. What you need to cover is Chapter 7, Libraries and Anti-Patterns, Chapter 12, Meta-Objects and Reflection, Chapter 13, Models and Views, Chapter 14, Validation and Regular Expressions, Chapter 15, Parsing XML, Chapter 16, Design Patterns. I'll go through the specific design patterns shortly. As most of you probably noticed by now, the prescribed book is not particularly useful with the design patterns. So have a look at tutorial letter 105. There is more information there. There's videos on most of the design patterns on my Unisa. And then also look at the recommended book by the so-called Gang of Four, the Elements of Reusable Code, which gives you a lot of detail about the design patterns. But don't just rely on the prescribed book for design patterns. It won't help you very much. You must look at the alternative sources as well. Then Chapter 17, Concurrency. Then you would also need to look at tutorial letter 104, which has got the information about networking. And then tutorial letter 105, towards the end, there's some information about cloud computing. You need to do the Azure Fundamentals Part 1 course. It's an online course, and the details of how to connect to it are in tutorial letter 105. You won't get any detailed questions in the exam on that, but there might be a question for 2-3 marks or so. So it's worth just having a look through that. It's very basic stuff, but it is reasonably interesting. So hopefully all of you are familiar with the syllabus and exactly what you need to know. The scope of the exam is basically everything, but I'll go through that in a bit more detail. Okay, scope of the exam. As I've just said, it's the entire syllabus, so you are expected to know everything. The emphasis will be on topics covered in assignments, and I emphasize it's the topics, not the actual questions. So if you've got a question in assignments on, say, reflection fixed properties, you could get a question in the exam on variable properties. So it's the general topic, not the specific question covered in assignments. But the emphasis certainly will be on what was covered in the assignments. That doesn't mean you won't get any questions at all on the rest of the syllabus, but there'll be relatively few marks. So the emphasis will be on what you did in the assignments, but don't rule out other parts of the syllabus entirely. You may well get questions for a few marks there. And then the specific design patterns we need to look at. Are the ones in bold are the main ones. The serializer pattern we had in the assignments, singleton, Memento, and factory method were the ones specifically mentioned in assignments. However, there is another one that sneaked in, and that's the strategy pattern. That question in assignment 2 on the calculator, although the question specifically mentioned that you must use the factory method, the question was in fact about the strategy pattern, because the strategy pattern is a pattern that allows a class to change its behavior at runtime and select different algorithms. Sorry, can somebody just mute their mic? The strategy pattern allows you to select different algorithms at runtime, which allows you effectively to change a class's behavior at runtime. And that question about the calculator did exactly that. It allowed the class to change its behavior between addition, subtraction, and division, and so on.
You've stopped sharing your screen, sir.
I didn't mean to. Am I back?
Yeah, you're back.
Okay. Right. So that question was, in fact, really about the strategy pattern, although it did mention the factory method specifically. Now, the slightly tricky thing is that those two patterns are actually often quite difficult to distinguish between. If you look at examples in that on the internet, you'll sometimes wonder what the difference between them is. One of the sort of obvious ones is that the strategy pattern has a context class as part of the design, but that context class only holds a pointer to the strategy. So there's not much functionality in it. And in many examples, you see the context is actually included into the client, which then leaves the strategy and factory methods looking very similar. And to make it even slightly more confusing, the strategy and factory method are very often used together. Because when you want to change strategy on the fly, it invariably means instantiating objects of specific classes, which you would then use the factory method for. So to get to the point, there is an example video on my Unisa, which goes through an example of the combined strategy and factory methods. Please have a look at that. It's not particularly complicated, but you do need to know about how the strategy and factory method work together. Then the way I mentioned earlier, there's not that easy to tell the difference between the two. The way you tell the difference is in the intent of the pattern. The strategy pattern is a behavioral pattern. The intent is to change the behavior of a class at runtime, whereas the factory method is a creational pattern. It is used to create or instantiate objects at runtime. And that is the main distinction between the strategy and factory methods, is the intention behind them. Strategy is to change behavior, and factory method is to instantiate or create objects. But please do have a look at that video. So although we didn't specifically directly mention strategy pattern in assignments, it was in fact indirectly there. Then another one that sneaked in is the facade pattern. And before I go into how that came about, the facade and the adapter or wrapper pattern, as it's sometimes known, that are also very similar. And if you look at examples of them, it's sometimes difficult to tell the difference between the two, and they in fact often get mixed up as well. But again, you look at the intent. The facade pattern is used when you want to hide the collaboration of multiple classes behind a simpler interface. So it's, if you have multiple classes working together and you want to give it a nice, easy interface to access all of them together, then you use the facade pattern. The adapter or wrapper pattern adapts an existing interface to another interface. So you would use this adapter pattern if you have a situation where you already have an interface, but it's perhaps not very suitable or not very good, or it's inadequate or something, then you use the adapter or wrapper pattern to provide a better or different interface. So the main difference between them is, again, the intent. The adapter or wrapper pattern comes in when there is already an interface and you want to change it. The facade pattern is when there's no proper interface and you have a probably fairly complex situation with multiple classes working together and you want to give it a one single simple interface. Now, hopefully you will recognize that that's exactly what you did in assignment 2, that guest house question. You had multiple classes which effectively made up a backend that all worked together. And the question was to add a simple GUI interface to get them all working together in nice, orderly, and simple fashion. So that was, although the question specified, it was in effect an implementation of the facade pattern. But for exam purposes, the ones that I've covered here in bold, and I'm going to sort of half include the strategy pattern in that, you must know well for the exams. You must be able to recognize them. You must be able to recognize the code. You must be able to write the code. You must be able to explain what they do and so on. That it's really just a more complicated form of the factory method, and that things like the adapter and facade, just have an idea what they are and what they do, but you won't get asked any detailed questions on them. But so you might get small questions for a few marks. You are expected to know what they are and what they are used for. Okay, so those are basically the exam scope and the specific design patterns. We're going to concentrate on the ones in bold, plus have a reasonable idea about the strategy patterns. The other ones you don't need to know much detail, but just be aware of them. And just talking about design patterns, if you look at examples on the internet, resources vary. Some are good, some aren't so good, and some of them are just blatantly incorrect. If you want to know the exact and correct and proper way to implement these design patterns, please look at that prescribed book or recommended book by the Gang of Four, Elements of Reusable Code. Part of the problem, if you look at the internet, implementations in different languages are not always exactly the same. If you do look at the internet, try and look specifically at the C++ examples, because they are not necessarily exactly the same as examples in other languages. And then one I'm not sure about, but the Memento pattern, which declares a friend. You will find some examples on the internet where it doesn't declare a friend. I think the reason behind that is language specific. I'm not sure about this. Maybe those of you know Java or C# better than I do. I don't think they have a direct equivalent of a friend. So as far as I know, that using a friend is probably specific to C++ implementation. So just be careful of that kind of thing. Just be sure what source you're looking at and what language the example is aimed at, because there might be differences for different languages. If you Google the pattern name and just add C++ to it, you will probably get better resources. As I say, just be careful of looking at examples that are meant for other languages. Okay, so much for the exam scope. Right, in the exam, is open book. You can basically refer to any resource you like. You can use Google, you can use notes, you can have crib sheets, you can look at the prescribed book, you can look at the exercises and assignments, you can type code into Qt and use Qt help and assistant, and you can use graphic software to draw UML diagrams. There are links to a couple of useful programs in, I think it was exercise 3 if you haven't got one already, but you can use graphic software as well. But just be careful with this looking at any resources. What you submit must be your own work. Otherwise, it is plagiarism. So do not try and copy and paste from other sources. If you copy and paste something from another source and submit it with your exam, you're effectively claiming that that is your own work, and it is not. So you're allowed to look at other resources. You can get inspiration, you can get ideas, but what you put down in your exam paper must actually be your own work, your own interpretation, something that you've prepared yourself. So do not just copy and paste stuff from other sources. It's not going to work out very well. And what you can specifically not do is communicate with any other person in any way during the exam or have any person present with you. And that is actually what IRIS is for. It's there to ensure that you write the exam without any external assistance. So that's what you can and cannot do. And just before I carry on, IRIS will be used for the exam. It can be set up for multiple monitors. I have mentioned it to Dr. Pilkington, but I'd suggest when you have your class with them in 2 weeks' time, just check with them or remind them because he has to specifically set it up to allow for multiple monitors. It's obviously much easier to write an exam if you have multiple monitors. It's a bit difficult to do. I'll get to the question shortly. I know it's a bit difficult to write exam just with one monitor. So if you do have access to a second monitor, just confirm with Dr. Pilkington that he will set it up for you. Then the big issue or problem with open book. Just do not think that an open book exam is easier than a closed book exam. It's generally not. The questions will invariably be a little bit more complicated, and they will be based on the application of knowledge and not just sort of copy and paste or regurgitating something that you find from a resource. And the biggest problem or feedback certainly that I got from students in recent years was that this open book thing wasted a lot of time and they ended up not finishing the exam. So you must prepare for the exam as if it's a normal exam and just use this open book thing as a bonus to maybe tidy up or get a couple of bonus marks here and there. But if you're going to go in the exam and hoping to use the open book as a primary source of information to get answers to something that you don't know about, the odds are you're going to come horribly short and end up only doing half the exam paper and failing horribly. Open book is only useful, in fact, if you are well prepared for the exam and if you know what you're looking for and you know where to look for it. If not, you can spend up a lot of time trying to look through sources that you're not familiar with, trying to find something that you might not recognize, even if you did find it. And I can assure you, if you don't know how to use a regular expression, you're not going to magically learn how to use a regular expression halfway through the exam. The open book might help you confirm which is the correct meta character used, something like that, but you're not going to learn how to do something that you don't understand during the exam. So just be careful of this open book. It has been one of the biggest pitfalls for students in recent exams, of taking up too much time looking through resources and then just not being able to answer the exam. Okay, sorry, I'm getting to the questions now. Okay, Jack Collins has posted a link to Refactoring Guru, and that is in fact one of the good resources that's site worth looking at for the design patterns. They're generally good detailed explanations. Dumasani's question, if I've made notes beforehand, can I copy and paste? Since yes, that's your own work, so that's not a problem. Percival's question, can I use my own regular expression validator tool that I created using Qt? Yes, you can do that. You can even use the online ones to validate a regular expression. But as long as you wrote the regular expression yourself and haven't copied it from a source somewhere, which is very unlikely anyway, you can, anything that you've written or composed yourself, you can copy and paste. You cannot copy and paste anything that somebody else has done. Are there any other questions on this aspect? Okay, open book, as I say, it's a good thing. It's a bonus if you're well prepared. If you're not well prepared, it's probably going to be what destroys you for the year. You cannot afford to spend a lot of time paging through resources that you're not familiar with. So just please be careful of that. Do not think that the exam is going to be easier because it's open book. Okay, JP Skitter, your question, go ahead.
Thank you, Doctor. Basically the same thing as earlier, just to reconfirm it. If I've done the exercises, am I able to copy from the exercises? I know that in this in this detail it says copy and paste from any source, but we can copy and paste from stuff that we've done. So
if you've written your own solution to the exercises, yes, you can copy and paste from that. Okay. But you can't copy and paste from the solutions that have been posted on my Unisa.
Understood. Thank you.
Okay, moving on. Okay, just some general information about the exam. Right, the timetable is now confirmed. It's Friday, 14th of October. The exam time is 8 o'clock to 10 o'clock in the morning. And note this one carefully. There's 30 minutes additional time to prepare and submit your PDF file. In the past, there was an hour. This year, there's only 30 minutes, which of course should be plenty of time. And please don't make the mistake of continuing to work on your exam after the time has expired. The IRIS is watching you. When your clock gets to 10 o'clock, you must stop working on your exam. The time left is purely to allow you to submit what you've done. Do not carry on working on it after the time is up. Then once again, confirming, IRIS will be used to invigilate the exam. The exam will be in my exams on my Unisa. Then please have a look at the discussion forum on my Unisa. I've added quite a bit of useful information there. It's in the COS3711 exam topic. Unisa prepared a training site where there's a lot of useful information about writing online exams. So please have a look at that. Then Unisa have organized some webinars, which are online classes very similar to this, going through all the exam procedures and using the invigilation and the ins and outs, and an interactive session so you can ask questions. There is a link to the schedule in the discussion topic, and the first one is on this Friday at 10 o'clock. There's quite a few of them organized over the next 2 or 3 weeks, but I'd suggest you do have a look at least one of them. There seems to be quite a lot of useful stuff there. But please don't go into the exam wondering or being unsure about how the whole exam process and IRIS and all that works. Trust me, during your 2 hours of exam time is not the time to try and work out how it all works. Just make sure you're well prepared, not only syllabus-wise, but for the exam writing procedure. Then there's a link to a mock exam. I'd just emphasize that it's not a COS3711 mock exam. It's basically an IRIS mock exam to make sure you know how to use IRIS and that you've got your computer properly set up to use it. There's in fact 2 things there for the mock exam. The one is a link to a mock exam site, which unfortunately doesn't include IRIS. It's the other 2 invigilation methods being used, but I've been told that students should have a link to the IRIS mock exam added to your My Modules. So please check your My Modules. You should have a link there for an IRIS mock exam. It's only CSET that's using IRIS. The rest of Unisa uses the Invigilator app and the Moodle app. But you should have a link in My Modules for the IRIS specific mock exam. Please have a look at that and make sure that your system is set up to use IRIS. You don't want to start your exam and find you can't start it because you can't get IRIS going. There's also a link on the instructions for using IRIS, which I suggest you have a look at. It's a PDF download, so you can look at that at any time. And then there's also a link for the IRIS plugin. Please note that IRIS, you have to download and install a plugin. There's separate plugins for Chrome and Edge, but you can't write the exam unless you have this IRIS plugin downloaded and installed. So please get it installed and then go to the IRIS mock exam and make sure that it's all working correctly. That's vitally important. Preparation for the exam writing process is, in a sense, just as important as your syllabus preparation. Okay, so I'm just looking at the questions again. If you have used IRIS in many past exams, has anything changed? No, Hannah, not as far as I know, but as I said, just go to the IRIS specific mock exam site and just check that everything's still working normally. Question from Kozinati, can we handwrite the exam? Yes, you can. I will deal with aspects of that towards later on. But yes, you can handwrite it if you like. Okay, where was it? Okay, then just moving on to some general suggestions. Okay, some of this is a bit repetitive. Please check that your IRIS is installed and working prior to the exam. It's vitally important. As I just said, you have to install a plugin. There is the link in the discussion forum. Do the mock exam. Again, it should be in My Modules. Make sure you know where and how to access your exam script. It should be in My Exams. You don't want to try and work that out on exam day. Then the exam paper for COS3711 has quite lengthy instructions, unfortunately, but please take the time to read them carefully. They are just fairly general, but just make sure that there's nothing in there that's going to catch you out. Then in your exam script, please include your module code and student number in your script. You know, Unisa has lost scripts in the past, and if it's floating around and it's got no student number or name in it, nobody will know which is your script. You don't have to put your name in. Your student number is sufficient, but you can put your name if you want to. And then just as a suggestion, your submission file, your PDF, name it with the module code and your student number. In other words, COS3711 underscore and your student number. But please identify your script properly. So you don't want it to get lost or mixed up with other people. Please mute your marks. And then this one is very important. As the feedback I've had from students in the past is that their biggest problem was running out of time. So I suggest that you draw up a schedule based on the total marks. The paper is usually out of 80 marks. I'm assuming it'll be the same this year. If presume it is still 80 marks in 2 hours, that means you need to do 20 marks worth of work every 30 minutes. I suggest you draw up a schedule and make a note of by what time you need to finish each question and try and stick to that. Now, if you've only got a line or two to write, finish it off. But if you reach the end of the time and you're not that close to finishing the question, rather leave it and go on to the next question. You will invariably get a lot more marks by starting a new question than you will by trying to finish off a question that you're struggling with. But please check your time carefully. Draw up a schedule. Keep track of where you are. Don't find out 15 minutes from the end that you're only halfway through the paper. But that's been one of the biggest problem areas in the past, is students running out of time. And so that's linked to the open book thing, wasting too much time looking at resources. Then I'm going to go through this in detail shortly. But your exam script will be similar structure to the past. There'll be a scenario. At the beginning, you must read that very carefully and make sure you understand it, because all the questions that follow are based on it. And if you don't grasp that scenario or you misinterpret it, you're going to struggle. Right? That scenario could be in any form. It could be text. It could be a UML diagram. It could even be code. The first two are the most likely. Most of the recent ones have been text, but it could also be a UML, and it's not impossible that it's code. There will be questions in the paper where you are given some code and you have to answer that. But I emphasize the scenario at the beginning. Just make sure you read very carefully and make sure you understand it. There's some very obvious stuff. Number your answers clearly. Please rule off after every question. Leave space between lines. Don't cramp everything up together. But make sure you mark your questions clearly. Don't leave it up to the marker to try and work out what question you're trying to answer. Remember, the marker's got about 400 scripts to go through, and if it's late at night during load shedding, you don't want to be a marker sitting there trying to work out which question the student's trying to answer, or trying to read tiny little font that's all cramped up together. So make your papers easy to read and make it very clear which question you're being answered. Then I'd suggest, and this is just my suggestion, if you're using a word processor, use a 12-point font size and a 1.5 line spacing. It's not compulsory, it's just a suggestion. Then those of you writing by hand, please check that you know how to convert to PDF format prior to the exam. For those using a word processor, it's a matter of saving as. But if you're writing by hand, make sure that you've got a proper app installed. Preferably use one that converts directly to PDF. Don't try and take a photograph and have to convert it or plug it into a word processor and save it. And please be careful if you're using a flash, taking pictures close up on white paper, you get a lot of glare. And we've had submissions in the past that you can barely read because of the glare. Just make sure you know how to convert your script into PDF format prior to the exam, and just make sure you can make proper and clear copies and not take too long about it. You don't want to spend 2 hours writing an exam and then stuff it up by not being able to do a proper PDF file that you can submit. Okay, I'm just going to look at some more questions here quickly. Okay, Tristan, your question about Linux, I can't really answer the question. Have a look at the IRIS site. There is a link on with the instructions that I've posted on my Unisa. As far as I know, IRIS is browser specific. There shouldn't really be any difference on using it in different operating systems. But look at the IRIS documentation. I can't really help you with that. So Firefox and IRIS before, okay. Yes, okay. So the problems with Linux, just look at the IRIS documentation. Okay. Okay, we won't worry about virtual machines and that, but yeah, I'm afraid that's an issue you're pretty much going to have to work out yourself. Or if you are having problems with that, I'd suggest you attend the webinars that Unisa is organizing and ask questions there. There will be people there who know more about it than I do and should be able to help you. Okay, I'm just going to try and change documents here. Okay, can someone just confirm, is that still being shared okay?
Yep, being shared.
Okay. Right, I think I've dealt with most of the questions so far. Okay, now we'll start going through the actual past paper. Right, everything in italics in this presentation is basically the stuff that's in the actual exam paper. I've just copied most of it here, but we'll go through it in detail. Right, this is the, sorry, I'm being distracted. Tati's pitched up. Okay, the scenario. As I say, read this through very carefully and make sure you understand it and have a good idea of what's in it. It's worth spending a good 15 minutes at least just reading through and working out the scenario. For this particular paper, the first question was worth 20 marks, which means you've got half an hour to do it. So you had half an hour to sort out the scenario and to draw a UML diagram. You should be able to draw the UML diagram in about 10, max 15 minutes, which means you can afford to spend at least 15, 20 minutes just reading through the scenario and extracting all the information. But it's worthwhile investing a bit of time in interpreting the scenario properly, because it will affect you throughout the exam. So just make sure you do this part carefully, and I will go through an example of how I suggest you do it. But let's go through the scenario. Right, many different vaccines are produced globally to help provide vaccinated persons with immunity from specific infectious diseases. Right, so you know straight away now that we're going to be dealing with vaccines. So there's one class already identified. And then the following points apply to a simplified scenario to be used in the exam. All vaccines, again, vaccines, so you know that's an important class that we're going to be using. Vaccines must be administered in some way, usually by mouth or by injection. So now you know that there's going to be a property that's got to store information about how the vaccine is administered. And it also says all vaccines should be able to return a string representation of its state. So you now know immediately that you're going to have a two-string method in all your vaccine classes. Then point 2, there are two types of vaccines. Inactivated vaccines, I'll come back to the brackets, and attenuated vaccines. So immediately now, you know, you've got a base class and two derived classes. So you've got a vaccine base class and you've got inactivated vaccines and inherits and attenuated vaccines. So we're looking at inheritance hierarchy. Then your inactivated vaccines is the information is when the infectious material has been destroyed using chemicals, heats, or radiation. So you know now that you've got a property that needs to record how the material has been destroyed. So you've got a destroyed property. And then your attenuated vaccines is, your attenuated vaccines is a process which is used to create them, involves disabling the virulent properties or using a closely related but less dangerous organism. So you've got to keep track of that. So you're going to have a process property that keeps some kind of information about that vaccine. Then point 3, the cholera vaccine is a type of attenuated vaccine. Okay, so now you've got another base class and derived class situation. And your cholera vaccines are normally administered in a number of doses. So again, there's another property. You've got to keep track of the number of doses. And then you have a rabies vaccine is a type of inactivated vaccine. So it's another inherited class and is normally based on a particular strain of rabies. So there you have to keep track of the strain. So just noting here, you've got a double inheritance. You've got a vaccine-based class, then you've got your inactivated vaccines and attenuated vaccines that inherit vaccine. And then you've got cholera and rabies vaccines that inherit from your inactivated and attenuated vaccines. So you've got a double layer inheritance hierarchy. So by reading through this, the most important thing is to identify all the classes that are mentioned. And you could at this stage then also have mentioned which properties each of them use. There's not much information here about methods. The only one you really know at the moment is that all of them must have a toString method. So if we then carry on with part 4, users should only be able to create instances of cholera, rabies, and similar types of vaccines. Okay, so you now know that you've got abstract-based classes. Your vaccine class, and sorry, I'm going to skip back, and your inactivated and attenuated vaccines are all abstract. You've only got 2 concrete classes, and that's cholera and rabies vaccines. So you've got a double inheritance hierarchy. 3 of the classes are abstract, and only 2 of them are concrete classes. Then there's a classic factory method design pattern. So you now know you've got a vaccine factory class, and that should be used to create instances of the types of inactivated and attenuated vaccines. Remember, that's the concrete classes of the cholera and rabies classes. Then there should also be an object contains a list of vaccine instances. So you know you've got a vaccine list. So now we should have been able to identify all the classes that are used in this scenario. As I say, take at least 15, perhaps even 20 minutes, go through, and what I suggest, as you go along and read through this, just make a note, a list of all the classes that are involved, and I'll go through a procedure how I suggest you do it now. But once you've identified the classes, you need to then start looking at their relationships, and the whole thing should start falling into place. Okay, so let's carry on. Okay, here's the actual question. Then, right, using all the detail in those points we've just looked at, draw a UML class diagram to model the scenario. Now, please, this part, read carefully. There should be enough detail to show how the data will be passed between objects. You do not need to include constructors or accessors mutators, nor show a client GUI class. In the past, some students have come short with this because they don't read this detail and they try and draw fully detailed UML diagrams with constructors and a whole lot of getters and setters and the like, and a client class, and they end up wasting half the time. In general, this type of question, although it's not necessarily the same every year, you must read the question carefully. The question is only really concerned about the relationship between the classes and the data flow, how data gets between the classes. You're not expected in a 2-hour exam to draw out hugely detailed UML diagrams with every bit of possible information in them. It's really the bigger picture, the relationships between the classes and how data moves around between them. But please read the question carefully to see what the specific requirements are. It's not necessarily the same every time, but don't get into a situation where you start doing things that aren't actually required. And then if the diagram is drawn by hand, use underline to indicate italics, and you just hope that there's nothing static in the diagram. Okay, question 1.2 we'll get back to. Okay, then how to answer a question like this. Obviously, different people will have their own ways of going about it, but this is the way I suggest. The first step is, as we've sort of been doing, is to identify the classes, the relationships, and then the methods and data members. What I suggest you do is draw up a table like this. It'll always have the same columns, and you're unlikely to get a UML diagram that requires, say, more than 10 classes. I really recommend it as part of your exam prep that you draw up a table like this beforehand, so that you've got it ready when the exam starts, and you can just go through and start filling in the class names. But what I recommend is that you first identify all the classes to this whole column. Sorry, I'm going to skip pages here. The factory and the vaccine list. just go through it. The first thing is get all the classes, because that's obviously the most important thing. If you don't identify the classes correctly, you're going to have a problem. So get that done first. Then go through each of them and work out the relationships between the classes. In this UML diagram, it's quite easy. Most of them are just a straightforward inheritance relationship. And then you get to the vaccine factory. It has two dependencies. It obviously uses the vaccine class, and then it creates the vaccine product. So that has two relationships. And then the vaccine list has an aggregation arrangement. It consists of, or is made up of, or contains vaccines. So those are the relationships. And then once you've got all that information, it's actually not very difficult to draw up the UML diagram. Then you were told at the beginning that all the vaccine classes have toString methods, so you can put all of those in. You're also given information about which were abstract classes, so you can identify those abstract classes straight away. It's only the cholera vaccine and the rabies vaccine that has methods that are not pure virtual. Remember, it's the pure virtual method that determines what a class is abstract, so you must show these pure virtual methods to indicate how the class or why it's abstract. Your vaccine factory obviously has the normal create vaccine method with the required parameters, and it returns a pointer to a vaccine object. Then the only one that for the vaccine list, it was specifically mentioned you must be able to add vaccines to the list. So you need an add vaccine method, because that is how the flow of data, that's how data gets into the list, through that add vaccine method. Again, for the vaccine factory, the flow of data is passed to the factory through its create vaccine method. So you must show this data flow, how the data gets to the factory and how data gets to the vaccine list. And then the final, then the final step, I mentioned as I went through, that if you, once you've got all this information together, if you reread it again, you will pick up the properties or the bits of information that each of the classes has to store. I think, although that scenario looks very complicated when you start, I think once you've gone through and identified the classes, it makes it much easier to start identifying which are the relevant methods, and particularly which are the properties and bits of information that each of those classes have to store. Obviously, the vaccine factory doesn't have any information it stores. Then the vaccine list, there's two ways of implementing it. If you do it by composition, then it obviously has to have a queue list as a data member. You can also do it by inheritance, in which case you must show it in your UML diagram. Then it wouldn't have a list, because it is itself a list. But I really recommend you prepare a table like this, have it ready before the exam, read through the scenario and write in each class as you identify it, and then slowly build up the information. Identify the relationship, then identify the methods, and then the properties, or the bits of data that are going to be stored by each of the classes. Just remember, for the methods, you only have to show the main ones, like this toString method was specifically included, and the ones that show the flow of data, like the create vaccine and the add vaccine method. Don't start adding a whole lot of getters and setters that aren't actually required. Okay, I'm just going to look at the questions again. Sorry, Jack, I don't quite get your question. The link to the IRIS prep, it does work, doesn't work. Okay, Jack, that link that I've put for the IRIS part, it's not actually a link. It's just a statement that you need to look in my modules. There, I've been told that all students have been linked to that IRIS mock exam in my modules, but I don't have access to it, so I can't see it. The link I've put there is to the general mock exam, which only includes the Invigilator app and the Moodle app. But the link for IRIS should be, each student should be linked in my module. So look in your general my modules, it should be there. But the IRIS mock exam in the discussion forum, that's not a link, that's just telling you where to look. Are we allowed to use third-party software to draw diagrams and then paste the diagram into our script? Yes, I thought I specifically mentioned that. Yes, you can use any software to draw your diagrams and then paste it into your answer script. As long as the diagrams are your own work, that's no problem. You can't use anything that artificial intelligence that does any creation for you. As long as you actually draw the diagrams yourself, no problem. Yes, Christy, indeed, it was mentioned earlier. Hannah, what does point 4 and similar types of vaccines refer to? Similar types of vaccines would be at the level of your cholera vaccine and your rabies vaccine. In other words, any concrete classes that are added onto the inheritance structure. But there aren't any in this example. It's just saying if there are other concrete classes. Murray's question, would we have to show step 1 in an answer sheet or just the final UML? No, you just have to do the final UML. How you get there is up to you. What I suggest is you do a rough sketch on a piece of paper, and once you've got it all together, then just draw up your final UML diagram. No, you just have to submit one final diagram. Okay, then I'm going to move on. Okay, I've done this. Okay, then I'm just going through the same thing step by step of how to go about. Once you've identified all your classes like this, you just start working through your list and adding them individually. So the first one we identified was the vaccine class. We know it's an abstract class. So we're showing a pure virtual method here, an abstract method. You can, if you want to add the equal 0 in there, but just showing it as being abstract is sufficient, and with its administered property. So that's your starting point. You draw in your vaccine class. Then the next thing is you add in all the derived classes. So you've got your abstract base class vaccine, then your attenuated vaccine and inactivated vaccine are also abstract. So you need to show the abstract to string methods. Remember, they're pure virtual methods. That's what makes them abstract. And then we've added in the property for each of those 3 classes. And then the final step in this inheritance hierarchy is to show the concrete classes. So we've got a cholera vaccine that inherits attenuated vaccine. You'll notice its to-string method now is not abstract. And then we have the rabies vaccine that inherits inactivated vaccine. Again, the to-string method is no longer abstract. And then each of them have those properties that we destroyed. Incidentally, for properties, just use Q-string in general unless you've got specific information where you're told number of doses, which makes it an integer. I don't think the type of your property is incredibly important. I think the issue is that you can identify the property. So you can just use something like Q-string, which would accept almost anything. So that then is the first part of your UML diagram. We've got our abstract base class vaccine and all its derived classes. And our scenario is now starting to fall into place. The next step is we add the vaccine factory. Right, the vaccine factory just has that one create vaccine method. Then the important thing is the relationships. Your vaccine factory uses vaccine because it returns a pointer to the vaccine class, and then it creates the concrete classes. It passes a pointer to those. What I suggest when you show these relationships, just put the text in, just in case you use the wrong line type or something. By putting the text in, you are showing that you do know what kind of relationship it is. It just makes it absolutely clear, and it helps prevent you from making a stupid mistake. But the important thing here is the classes and their relationships, using the right inheritance lines, and then showing this creates and uses relationships. It doesn't matter if this line is dotted or pointed. So it's not a test to find a detail. It's just that you know or can identify the relations between the classes. And as I said, rather put that text in. It just makes it clear that you do know exactly what it is. And then the last step is to add in the list. So you add in your list, and has an aggregation, a relationship with vaccine, because your list contains or is made up of vaccine objects. And that then is the UML diagram for question 1. So at first look, that scenario seems very complicated, but if you take the time and go through it carefully and identify each of the classes, it starts falling into place, and then you can identify the relationships, and then identify the properties and the methods that pass the information between the classes. I emphasize this question only asked you to show the methods that show the flow of information between the classes. That's only really the vaccine factory that does that, in the list where you have to add vaccines. There isn't much else to show, so don't get sidelined with adding all kinds of getters and setters and constructors and things that aren't required. Just read the question carefully and make sure you understand what is required. Okay, I'm just going to make questions again. Hannah's question: why does the virtual method need to be repeated in the inherited abstract classes? Because that's the way inheritance works. If you don't put it there, then the concrete classes aren't going to inherit that toString method. Your rabies, your concrete classes need to have that method in it because it will be using polymorphism. They need to be virtual in each of the abstract classes, and if you leave it out of the middle abstract class, your polymorphism is not going to work, because you would be using a base class pointer and the chain would be broken if the toString method wasn't, virtual toString method wasn't in the middle abstract class. So you need to keep the chain intact of virtual abstract methods all the way through to the end. Gustav question: can we make the lines and arrows normal, but just have the label that says aggregation or inheritance? Can we make the lines? Okay, Gustav, I'm not quite sure what you mean by lines and arrows normal. I thought they were normal. As I've said, it's not critical to use a dotted line. You can just use a solid line. But yes, it is, I think, a good idea to add a note or label that specifies exactly what the relationship is, just in case your line is not clear. Jack, so I'm reading Jack's question and thinking about it. Would we lose marks if we did something like put doses as a property in the vaccine class? One could argue that all vaccines require a dose. Yes, Jack, I suppose vaccines do require a dose, but there was nothing, as far as I recall, actually in the scenario that mentioned or would lead you to that effect. So you probably wouldn't get marked wrong if you put it there, but my suggestion is don't try and overthink it. You're trying to think of a real world scenario. You need to just work on this little fantasy scenario that we've got. Don't try and look for information that's not there or try and relate it too much to a real world situation. Rather go on, base your answer on the information that is actually provided. Just remember, you may get a scenario that doesn't totally relate to the real world. So to answer your question, I doubt if you'd be marked wrong, as long as you have identified, should we say, a reasonable property for each of the classes, and you won't be marked down if you use a different name or something. It's not an absolute fixed thing. As long as you've got something that's sort of reasonably sensible and makes sense, you'll get your marks. But yeah, don't try and overcomplicate it. Don't look for something that's not there. Okay, any other questions? Okay, moving on. Okay, question 1.2, a little filler question. Why would a factory method design pattern be more appropriate design than an abstract factory design pattern? 2 marks. Okay, this is really asking, do you know the difference between the abstract factory and a factory method? Okay, any kind of answer that illustrates that you do have some idea what the difference is, and as long as you address something along the lines of that there's only a single product, whereas an abstract factory is only required if there are multiple products. You know, if you have a single product with an abstract class, you would have an abstract class with a single derived class, which is a bit of a waste of time. It's just not necessary. You would only need an abstract base class if you have multiple derived classes. And just remember, the abstract factory is basically just a more complicated situation of a factory method. So any question, any answer along those lines that indicates that you understand the difference between them, it's not something that is an absolute fixed right or wrong answer. As long as you indicate that you do have some idea or understanding of what the difference is, you will get your marks. Microphones off, please. Okay, question 2, 24 marks. Right, so question 2, you could allocate yourself just around 30 minutes, over 30 minutes for this. Notice now that this question follows on from the same scenario, and it gives you some information about the process of adding a vaccine instance to the vaccine list is as follows. An application is run by the main GUI client as a separate process, right? So you know we're heading down the concurrency road here with queue process that gets vaccine details from the user. The data is returned to the main GUI client as a string via the process's standard output. Okay, so now you should be recognizing that we are looking at using signals and slots for this because that's how the standard output works with the queue process. Then using the factory method, an appropriate vaccine instance is created in the main GUI client. Right, so you would need to instantiate an instance of the factory method, pass the appropriate parameters, and you end up with your appropriate vaccine instance. And just remember, when it says vaccine instance, appropriate vaccine instance, you look at one of the derived classes, of course, not the vaccine class itself, because that's abstract. This instance is then added to the list of vaccines, which is really logical, but now comes the complication. When a vaccine instance is added to the list using inter-object communication, right, signals and slots, a signal is automatically sent that is made up of the string representation of the vaccine instance that was added, as was noted in point 1 in the scenario at the start of the exam paper. And that point 1 was that all vaccines should be able to return a string representation of a state. So all you're doing, all this is saying is that you need to call the toString method to get the string representation of that specific vaccine class. This signal is then picked up by the main GUI client and leads to the text being added to a queue list widget on the main GUI client. Okay, so you basically got to add use the factory method to instantiate one of the derived vaccine instances. You then add it to the list. When it gets added to the list, a signal gets emitted, and that signal gets read in a slot, and you need to extract the string information about the specific vaccine and then add it into the queue list widget. Again, just read through that carefully. It might seem a little complicated at first, but if necessary, draw a little sketch on a piece of paper or something and follow the flow of information. But once you work it out, it's actually fairly logical and not too difficult. Okay, then you're also given the outline of the head of the main GUI client, which makes it a bit clearer. You'll notice that this exam script was back in the days when Qt Designer was still allowed. And what you're basically given here is that there is a slot called create vaccine. So you now know what you have to connect to. Then to get to the actual question, an application named vaccine data exe. Mac users, you're just going to have to pretend you're using Windows or think in Windows terms for this kind of question. Can be used to gather vaccine data from a user. Write the code that runs this application as a separate process where its output is managed by the function in the main GUI client named create. Okay, its output is managed by the function named create. So create is obviously a slot. That's where the output is received. And that's where you get full marks. Okay, so the first thing you need then is to declare a queue process. And all you need to do is new process. And it's quite important that you do this if you're using a pointer. Otherwise, you're going to have difficulties with destroying that or deleting that pointer. I've specially left a space here because you need to declare this process as a class member because it's going to be accessed from two different slots. So just be careful about the way you answer it. Don't declare that within a method because then you won't be able to access it in the other method. So you must make some kind of a note that it's declared globally or as a class member outside of the slots where it's going to be used. Then to run a process, all you have to do is call it its start method and pass it the name of the program that's going to be run as a process. And then the important part is connecting the signals and slots. And in order to get the information, you need to connect the ready read standard output, right? That's the output that's produced from your process and connected to a suitable slot where it's going to be read. And in this case, it's called create. You were given that where its output is managed by the function named create. So that's all you need to do to answer this question. You need to instantiate a process object, remembering if you use a pointer, this part of it. You call the start method, pass the program name, and then connect the signal that generates the output to a suitable slot. And that was all that was required for this question. It should be fairly simple and straightforward. Then moving on to question 2.2. Now you need to write the code for the create function. Remember, in this first part of the question, we linked the signal from our process to this create slot. That's where we're going to receive the output from the process. So now you need to write the code for the create function. It retrieves the output from the application process into one and calls the following factory method code to create an instance of a vaccine. Okay, you're given a lot of the code in this exam paper. Quite honestly, I think it's made a bit too easy. You're given too much. But anyway, you're given, this is a very standard vaccine factory, create vaccine call where you simply pass all the parameters. And then based on the type, which was the first parameter, you return the appropriate vaccine object, whether it's cholera or rabies. And there's always or should be the default option. Just as an aside, this is where a lot of you came short in assignment 3. setting up your factory method, because you had what was appeared to be a bit of a complication, and you had cylinder and box objects that had different number of parameters. A lot of you struggle to deal with that. We had a lot of people overloading this create vaccine method to overcome the thing of different number of parameters. That's completely wrong way of doing it. You're defeating the object of using a factory method by effectively predetermining what type of object is going to be returned. The way it should have been solved was setting up your create container method so it could handle a different number of parameters. You could use either default parameters or just have an additional parameter. Remember, if you have a method that's got, say, 4 parameters, you don't need to actually use all 4 of them within the method. You can just use 3 of them. So when you call the method, you could have just added a dummy argument to it. But the correct solution was to only have one create container method and to handle the different number of parameters by using default parameter or dummy parameter, and then not using all of the parameters within the method. But anyway, we're digressing. Right, the output from the application, read from the standard output, is in the form vaccine type asterisk argument 1 asterisk argument 2 asterisk argument 3 asterisk. You need to look at that fairly carefully because, quite honestly, when I first looked at it, I fell into the trap of thinking those were pointers. They're not. They're actually just separators between strings. So just be careful about things like that in exam. It's quite easy in exam conditions to misread something. And then you don't need to include the code for adding the instance to the vaccine list. Okay, it's only 1 line anyway. Right, you get 8 marks for this. So let's have a look at it. Okay, the answer, right, this is our create slot. Remember, the process read all standard output method is how you actually read the output after you've received the ready read signal. And that returns a Q byte array. So you need to declare Q byte array to receive the output from the process using the ready all standard output method. Then because there are multiple parameters, sorry, I'm just going back again. You were given 1, 2, 3, there's 4 parameters with a separator between them. So the easiest is to use a string list to receive it. You take your input Q byte array, you can convert it to Q string simply by calling the Q string constructor. There's a Q string constructor that accepts a Q byte array as an argument. And then you just call the split method of Q string, you split it on those asterisks, and that splits it into a string list with 4 items in it. You declare vaccine factory and a vaccine pointer, and you pass it the your vaccine factory create vaccine returns a new vaccine to it, and based on the type that's passed to it, will return the correct type. I'm just going to go back to it. So if you pass that argument as cholera, it will return new cholera, and then with the appropriate arguments passed to the cholera constructor. So you've received your input from read all standard output, you put it into Q byte array, you converted your Q byte array to a Q string, then you split that string into a string list, and you then pass those parameters to the vaccine factory's create vaccine method. And remember, string list you can treat like an array, so you just access the first, second, third, and fourth items in your string list. And that's all that was required for 8 marks. Are there any questions on that? If you've done Q process examples, this should be pretty straightforward. There's no complications in this at all. Okay, I'm just stopping for breath. Right, no questions. Okay, well, hopefully you can all find that quite straightforward. Then question 2.3. Write the code for the class declaration of the vaccine list class, as well as the implementation code of the function that adds vaccine instance to the list. Remember to take note of the process given at the start of this question, specifically point D. That's for 8 marks. So point D was about using where am I? Oops, sorry, I'm going the wrong way. Point D was about using inter-object communication, in other words, a signal. So you had to implement a signal within this code somewhere. Right, so our vaccine list, okay, because we're going to be using a signal in the vaccine list class to tell when a vaccine's been added, it needs to inherit Q object. So don't forget that. And again, because you're using signals and slots, you need to include the Q object macro. Then we just have the normal constructor, and then this method add vaccine, which adds a vaccine pointer to our list. Then the important part here is to implement a signal along the lines of vaccine added, which you need to pass a Q string as an argument. And then this example, we've used composition for the list, Q list of vaccines. You could also do this by inheritance, in which case you would have multiple inheritance. You'd have to inherit Q list and Q object, but it can be done that way. It's also acceptable. But that generally is what your declaration of the vaccine list would look like. So the important things are that you've got the method to add the vaccine, and you've got the signal to emit when a vaccine is added. And then the list part of it, you could do either by composition or inheritance. Both are acceptable. And just a general note, you don't have to include any of the includes or any preprocessor directives, preprocessor, unless they're specifically asked for. In general, they aren't asked for. For the exam, we're more interested in that you know how to actually write the code for the various methods and that, and not the finer points of using Qt. So please don't waste time adding a whole lot of includes or preprocessor directives. It's very unlikely, but if they are required, they'll be mentioned specifically. But otherwise, don't worry about those at all. Don't waste time with them. So this list declaration should be fairly straightforward. Then the next part of the question, the add vaccine method, it gets passed a pointer to a vaccine. Then all you have to do is in your list, which would have been declared as a class member, you append the vaccine pointer to it. Then you compose the message, and all you have to do is call the toString method on the vaccine, because that's got all the information about the vaccine in it. And then the important part about this question is then to emit the signal, the vaccine added signal that you declared in your declaration with a string argument. You just emit that and use the toString form of the vaccine as its argument. So again, that's very simple. Shouldn't be any complications with that. I know it's a bit different under exam conditions, but now please don't get the idea that the COS3711 exam is difficult. It's not actually that difficult. If you know your work reasonably well, you should be able to pass the exam quite easily. As I know it's a bit different when you're under exam pressure and you only got 2 hours. But if you read the questions carefully and think about what you're doing and allocate your time properly, you shouldn't find it too difficult. Okay, question 2.4. No questions about that. Okay. In point E in the process above, the text containing the string representation of the vaccine instance is added to a Q list widget on the GUI. The following code has been provided where UI list widget is the Q list widget variable and string is the string representation of the vaccine. Okay, so you've got some code here which makes the obvious statement. However, this code is not working correctly. Make the necessary corrections for 2 marks. and it's got some obvious errors here, because you wouldn't be declaring a pointer to a list widget at this point. That would be a class member that would have been done in your constructor. You can't really set text on a QList widget. It just doesn't work that way. And then a list widget doesn't actually have a set item method. So this code is sort of pretty much incorrect, and you need to fix it. Basically, you know how to use a QList widget. And then looking at the solution, sorry, I was running out of space here. These two solutions are different. That first line and the last three lines are two separate solutions. The first one is that QList widget actually has an overloaded method that accepts a Q string. So if you call the insert item, the syntax here is the first item is a row number and the second item is the string that you're passing to it. Incidentally, you can use any row number that's incidental to the question. So you could have put any digit in there. What this does is actually it instantiates a QList widget item and then sets its text to string. So using this insert item method with a string argument is actually an all-in-one. It's obviously the easier way to do it. But the alternative, and based on the code above that this question was obviously actually asking for, is the first line here declared a QList widget. What you're actually going to do is declare a QList widget item. In other words, it's the item that's used as the data in your QList widget. And it's a new QList widget item, not a QList widget. So that was the first correction you had to make. Then with this new item now being a QList widget item, the second line is in fact correct as it was, because a QList widget item, you can set its text by passing a Q string. So making the correction in the first line made the second line correct. And then the third line is the method to call was not set item, it's insert item. And I say, again, you can use any row number, and then you pass it an item, which is a QList widget item. So you just had to make those corrections in 2 lines, and that would have got you your 2 marks. Again, being able to answer this question would, you would have to know how QList widgets work. This is the kind of thing you could have looked up in the Qt documentation and probably found reasonably quickly if you're familiar with how to use the Qt documentation and to find what you're looking for. But again, that wasn't a particularly difficult question. The crux of it was that you had to be able to recognize or certainly have a good idea of what the issues were with the code that was given. But once you could work that out, it's actually quite easy. Okay, question 2.5. Could a QStringless model have been used instead of a QList widget? If not, explain in detail why not. If it can, explain in detail how it could be achieved. Note that there are no marks for indicating yes or no. So this question, as are most of the questions in the exam, are looking for your understanding of what's going on and your ability to apply knowledge. Just answering yes or no, which doesn't show or give any indication that you understand what you're doing, doesn't cut it. So the answer is that you generally had to explain the difference between the convenience model view class, in other words, the combined model and view, and a normal model view, which is a separate model and view. And the answer then is that you would need to add a view class such as QList view in order to use QStringlist model. So basically you just had to demonstrate some understanding that to use a QStringlist model required a separate model in view, and that the QList widget is a combined model in view. So any kind of answer along those lines that illustrated that you didn't know the difference between a combined model in view and 2 separate model in view is would have been acceptable. Again, it just goes to your understanding the difference between the convenience widgets and the full model and view classes. Okay, getting back to questions. Hannah, for the mid signal, how do you then connect it to a slot? Hannah, the answer is absolutely normal connect statement. It's a normal signal and a normal slot. There's no difference to doing that as for any other connect. And Christie's question, the same way you did for push button. Yes, that's correct. And there's an example for you. Still use the signal, not the function that it was emitted in the connect. Okay, I don't quite understand your follow-on question, Hannah, but basically you connect a signal to a slot. It's absolutely standard. It doesn't matter if it's a user-defined signal or if it's a built-in signal. The connect statement is still the same, and the structure is the same. You just connect a signal to a slot. It's only the names that have changed. Okay, moving on. Okay, question 3, 21 marks. Okay, again, this question 3, given those 21 marks, you should have about 30 minutes to do this. So I'm going to keep on pushing them. So please allocate your time carefully. It's very important. If you run over time on a question, you're going to struggle. Rather than going over time on a question, leave it out, carry on with another question and come back if necessary. But don't spend too much time on a question because you're unlikely to pick up a lot of marks but struggling to finish a question. You will get more marks by starting a new question. So don't waste time on a question. If you've taken too much time, move on. Okay, question 3. The vaccine list should be saved as an XML file when the application closes. Assume a My Vaccine List class with the following interface. Okay, it has a size method that returns the number of items, and it has an @ method that takes an integer and returns a pointer to that object. Just note here, this does to an extent depend on how your list was implemented. If it's composition, then you need to define these methods. If it was inheritance, then these methods would be built in and you wouldn't need to specifically define them. And then you're given a structure for the XML file. You've got a root of vaccine list, and then you've got vaccine elements, which has an attribute of the class type, and then the various properties that go in the administered, process, doses, etc. So it's a fairly straightforward XML structure. So you just need to write the code, or the question will no doubt be to write the code that produces this output. And there's always a complication. Question 3.1. Reflective programming methods will be used to access data from vaccine instances in the list. Explain in detail what needs to be in place and the classes involved to allow this to be implementable. You should indicate clearly what needs to be done and which classes. And there's 5 marks on it. So you need to indicate clearly what needs to be done in each classes. So the first thing you do is list all the classes, because you have to clearly indicate what needs to be done in which class. So the first one is the vaccine class itself. Obviously, to use properties, it has to inherit QObject. Then you also, as you hopefully know, you need to then implement the QObject macro and also the QProperty macro to define the fixed properties. Then in all the derived classes, the attenuated vaccine, the inactivated vaccine, the cholera vaccine, and the rabies vaccine, notice that they get access to QObject by inheritance, so you don't have to do anything about the QObject again, but you must implement the QObject macro again in the derived classes. The QObject macro is not inherited. It has to be present in each class that wants to use the facilities of QObject, such as signals and slots, and the QProperty macro. If you don't include that Q object in the derived classes, you won't be able to access the properties that you define in that class. So in the derived classes, you need to add the Q object macro and the Q property macro for each of the relevant properties. Then vaccine list, which is also a class that uses the vaccines, there's no changes required. So basically, you just need to mention each class and specifically state what needs to be in place to allow you to use reflection. Generally, is the base class must inherit Q object, and all the other classes must have the Q object macro and the Q property macro. And that's it. You should know that from reflection. Okay, then to get to the actual sort of question, right, use DOM to write the data from the vaccine list to the XML structure given above. Consider the following declarations and partial code where the vaccine list is passed as a pointer to the right function. Remember to use reflective programming techniques so that the code is as generic as possible. Okay, then you've given the basic DOM structure here where the DOM document and the root and so on are declared. Sorry, things too sensitive again. And then you've got the right method. Okay, there's a slight complication in this exam paper, so I wanted to talk about this generally. For some reason, this DOM document and the root in that was declared outside the right method. So as it stands, they're not actually accessible inside the right method because there's nothing here that says that they're defined as class members. So if you come across a situation like this in the exam, you must just make a reasonable assumption and just push on. And what you should have added here was just your assumption is that those objects can all be accessed inside the right method. I asked Dr. Pilkington specifically about this, and that's what he told me. If you do find something that doesn't seem correct or logical, just make an assumption, note your assumption, and move on. If by some chance there is something blatantly incorrect that makes the question sort of unanswerable, the question won't be marked and the total marks available for the exam will be reduced accordingly. So you won't be penalized in any way if there are by any chance errors or typos in the exam paper. As I say, if it's a small thing, just make an assumption and move on. But you won't be penalized if you make, say, a slightly wrong assumption and so on. It's the idea is not to trick you or catch you out. But yeah, don't be thrown off if there happens to be a typo or a slight error. Just deal with it and move on. But if you do make an assumption, just write down what you're doing. There is another one, as we'll see later. This QDOM document was referred as XML doc, and further down it's just referred to as doc. Again, when you come across that, you should just make a note that you assume it's actually referring to the same item. Okay, so you're given this basic code then of looping through the items in the list. And the first thing here is to get the meta object. The writing in bold is the where you have to produce the code. And you'll see all the items, set up the vaccine tab, loop through all the instances, properties, access properties, create the XML tags is what you have to provide. Then you're just given the code to write to file. As you notice there, it refers to doc instead of XML doc, but that doesn't really affect you. That's just there to complete the example. You don't actually have to do anything. So the question is, supply the code where specifically required, indicated in bold italics, so that the data in the vaccine list is written to file. So it's 15 marks, basically for filling in the blanks where the bold italic items are. So let's take a closer look at that. Okay, I'm just reproducing the actual loop here because we're not actually using the rest. Okay, get the meta object. All you had to do was access the appropriate item in the list, and that's using that at. a method that was defined earlier, and then call the meta object a method of QObject, and that returns the meta object, which we will then deal with later. So that was the first thing you had to do, show that you know how to retrieve the meta object. Then setting up the vaccine tag from the meta object, you can retrieve the class name directly. It returns QString, that gives us the class name. Just as a side note, this is where a lot of you fell short in the assignments. You didn't know how to retrieve the class name using meta object, and a lot of you used weird and wonderful things of adding type properties to the classes and get type methods and all kinds of things like that. That information is readily available from the meta object, and we did examples early in the year. You should know that you can get the class name directly from the meta object. That's how reflection works. We then declare a DOM element, in this case named vaccine, and we call the create element a method of QDOM document, passing it the name that we want to use. Oops, sorry. And then we use that element, a vaccine that we just created, and we call it set attribute method, and we set an attribute with the name of class, and its data is the class name. And then we append this vaccine element to the root. So there we've set up our first vaccine tag, and that's obviously within loops, so it'll just loop through into all of them. Then for this specific item in the list, we want to loop through all those properties and extract all the properties specific to this item. Okay, looping through all the properties, we do a normal for loop, integer count equals 1. Notice that 1, I'll get back to that. And we call the property count method of the meta object. That tells us how many properties there are, and we can just loop through all of them. Right, remember your Q object has a fixed property, a default fixed property. The object name is always the first fixed property. We're not interested in it for this particular question, so we only start looping from 1. In other words, the second item in the list of properties. There are other ways of doing this. There is I've forgotten the exact name, an offset method that calculates where the first fixed properties start and where the first variable properties start, that you could also use. Again, this was a place where a lot of you came short in the assignments. You started looping from 0. And then I saw some really weird and wonderful solutions that started from 0 and said if its property name was object name, then break out of the loop and carried on. And incidentally, those of you who wasted your money and paid 249 Rand to Stuvia, that's where you came short, because Stuvia used that very stupid method and they stood out like a sore thumb. We had 30-odd students all making exactly the same error in the assignment with exactly the same code. So the Stuvia submissions were all actually located within a couple of minutes, and all of you will be getting a big fat 0 and wasted 249 Rand buying your solutions. Guys, I just don't get it. Students in 3rd year of a final year subject buying solutions and then submitting it as your own work. You're really just wasting your time and money. It took us just a couple of minutes to locate all of them. As a matter of interest, 29 students bought solutions from Stuvia. We've so far identified 33 solutions based on the Stuvia solution. So it seems that even the scammer got scammed. Some of you, there's more of you using solutions than paid for them. Anyway, you wasted 249 Rand. Okay, moving on. So you loop through here, starting from the second item in the list of properties, and then you access the instance properties. And the way you do that is by using the QMeta property class. And And the way you get the meta property is by calling the property method of QMeta object, and you pass it the integer count as an argument. And from that, you can get the property name by calling the name method of QMeta property. Just take a note here that that name method returns a constant character, which is a complication in some cases. I'm not sure if there's been a change in Qt in the latest versions, because there was a time that you couldn't use that constant character directly to a Q string. You had to convert it basically from constant character to Q string. One of the ways was by calling this from UTF-8 static method. But nowadays it seems to work directly, so I don't know if something's changed, but just be aware that this is actually returning a constant character. I'm sure in the past it gave errors if you tried to assign it directly to a Q string, but it's going through fine. I'm using Qt6. So, as I said, I don't know if something's changed, but anyway, just be aware of that. And then the property value, you call the property method on your Q object, in other words, the item in the list, and you pass it the property name. Just remember, it returns a Q variant. So you call the toString method, and that then will give you the property value as a Q string. Just remember, there's the first one, you're calling the property method on QMeta object. It takes an integer as an argument. Calling the property method on a Q object, it takes a Q string as an argument. Those are two different methods belonging to two different classes, although they've got the same name. Okay, so now you've got your property name and your property value. You now create the tags. You create a QDOM element. In this case, it's named property. You call the create element method on your DOM document, and you pass it the property name. And then for the text part, you create a QDOM text, which I'll call property text. And you call the create text node method on your document and pass it your property value. And you then append the property text to the property, and you then append the property to the vaccine. And you just keep looping through until you've picked up all the properties. So this is just an absolute standard DOM document writing. Again, it's the kind of thing you've done in the exercises and the assignments, so you shouldn't have any difficulties with this. But please, particularly, I'm going to go back a step. This QMeta object and getting the class name, that's for some reason where students seem to fall down. Please take note of that. It's an important part of using reflection, is being able to identify the object type directly by reflection. Okay, so that's all of the DOM writing. Are there any questions about that? No. Okay, question 3.3. It has been suggested that SACS could just as easily be used to generate the XML file. Comment on the suggestion. Not obstacle filler for 1 mark. And the answer is no. SACS can only be used to read XML, whereas DOM can be used to read and write. SACS is read only, so you just need to be aware of that difference. But anyway, trivial question, which you should have had a bonus mark for. Okay, then question 4. 15 marks. 4.1. An optional property may be added to a vaccine instance indicating the authorization code of the user who added it. The code should be made up of 3 to 5 uppercase alphabetic characters followed by a hyphen and then 3 digits. An optional final character may be included. Okay, so there's a fairly straightforward scenario, and then the questions you have to answer are: you must provide an input mask indicating where the mask would be used. the regular expression that could be used to ensure that a valid value is entered. You get 4 marks for your regular expression. Assuming a vaccine instance named VAC, add the user authorization code to the instance's properties. And is it necessary to use both the input mask and regular expression to ensure a valid entry explaining why you say so? Note that there are no marks for indicating only yes or no. Okay, that's reasonably straightforward. Then the answer for the input mask. Okay, I didn't indicate where it can be used. Okay, you would use the input mask, you link it to a Q-line edit, of course. Okay, this input mask, the first character converts everything that follows to uppercase. We then got 3 compulsory digits. Just remember, for an input mask, uppercase doesn't mean that it's an uppercase character. It means it's a compulsory character. And then the lowercase a's means they're optional characters. So there we've got 3 to 5 characters, 3 compulsory and 2 optional. Then a fixed hyphen, and then 3 compulsory digits, and then an optional character. Again, remember the lowercase means it's optional, uppercase means it's compulsory. That's a pretty straightforward input mask, which you should be able to do quite easily. Then the regular expression, I just want to say this is just one way of doing it. There are obviously some variations of doing it, but we've got a range here of A to Z capital letters, and then the numerator is between 3 and 5 inclusive instances of it. So that's how you get 3 to 5 capital letters. Then there's a fixed hyphen. Then we've got a group of 0 to 9 digits and 3 fixed instances of it. You could have used different ways of showing this here, like the \D, for example. And then we've got for the optional character, there's a wildcard with 0 or 1 instances. That wildcard might not be the most appropriate thing because it did say character, and wildcards allow all kinds of things in. So it might have been a better choice to say a range of A to Z capital letters and A to Z lower with the question mark, 0 or 1 instances, but you'd get your marks for either of those. So that's just one way of doing that regular expression. As I say, there are variations you can do on that, but as long as you had something along those lines, you would be okay. In setting a variable property, you just use your object, call the set property method, and pass it parameters, the name and its value. Okay, I just realized there's a extra inverted commas there. Leave that little bit out. But yeah, you just pass it a name value pair, and that's how you set a variable property. It's very easy. Then the question about input mask. Sorry, what was the question? Is it necessary to use both input mask and regular expression to ensure valid entry? And the answer is no, because an input mask, you can skip characters. So it's not an absolute, it's more of a guide than an absolute validation. So you can use a regex and an input mask together, or you can use a regular expression only. But you just need to demonstrate that you can't use an input mask by itself because it doesn't provide full validation. Okay, question 4.2, we get on to the Memento. The following vaccine Memento class has been used to provide runtime backup for the vaccine list. However, it is leading to errors. Rewrite the code so that errors are fixed and the classic Memento pattern is implemented. It's only 2 marks, so it's obviously not anything really complicated. So you're given a Memento class implementation, declaration here, which has obviously got some shortcomings in it, and you just have to fix it. And the things you need to fix is that you need to declare the originator as a friend of your Memento, because everything in the Memento is private, and if you don't declare it as a friend, it won't be able to access it. As I say, you will find implementations on the internet where they omit this friend class, but using the friend is definitely the correct way of doing it. If you look at the Gang of Four's book, Elements of Reusable Code, and I speak under correction, but I think the implementations that omit that friend class are using other languages, and friend might not be an option there, but I speak under correction. But friend, declaring the originator as a friend is very definitely a required part of the Memento pattern in C++. Then the other thing that the sample omitted was a means of storing the state. You've got a getter and a setter, but no way of, or nowhere to actually store the state. So you needed to add a list, in this case, a list of string lists to store the state. So to get your marks, you just had to add those two lines, the friend, declaring the originator friend, and adding a means to store the data in the Memento. So I think for this exam, students got off very lightly with the Memento pattern. The Memento came up in a couple of assignments this year, so I think there's a very good chance it's going to come up, and I'm just guessing. I haven't seen the paper, but I would suspect it would be a rather more detailed question for you. So just make sure you're familiar with the Memento. It does come up in pretty much every exam, and as that came up in more than one assignment this year, so I think that's an indication that you can expect it in the exam. So just make sure you know your Memento quite well. And question 4.3. An often given advantage of cloud computing is that there's no longer the need to guess infrastructure in-house capacity. Explain what this means in terms of the scenario used in the exam. There's 3 marks. So your cloud computing is a very simple question now for just 3 marks. Again, there's no sort of real absolute or fixed answer. You just need to indicate that you're aware of the issues, and it revolves around this sort of discussion, is that the vaccine list size is unknown, so the storage requirements are unknown, and it may vary quite substantially, and that could lead to wasted capacity or insufficient storage. And the advantage then is that cloud storage facility can be scaled up or down as required and at very short notice. And that's with no capital outlay or redesigning your systems or anything like that. So sort of anything along these lines that indicate that you understand what the issue is and the advantage of scalability and increasing or reducing capacity at short notice, and at basically no capital cost would get you your marks. So it's not a fixed answer, it's just that you indicate that you understand what the issue is. And that basically is that. Are there any questions, guys? Other than that, there'll be a session again next Wednesday when we'll do the October-November exam paper. Okay, Tristan's question. Is declaring the friend in the private section the reason why you can access the private member variables? As minus one always, that is only allows access to protected. Now, Tristan, we're not dealing with inheritance here. Your protected only comes into play when you're using inheritance. If you declare another class as being a friend of the current class, it gives that class full access as if it were the class itself. So yes, declaring the friend is the reason why the originator can access the private member variables, because it gains the exact same right to the class as the class itself. It's got nothing to do with protected. Yes, Joel, I won't repeat your comment, but yes, that does sum it up. Marley's question is next week's session at 17:30. The session will actually start at 1800, but I will be connecting up at 17:30, and in that time you are welcome to ask questions or have any discussion, but the session itself will start at 1800. It will be accessible from 17:30. Where can we get a copy of the slides after the session? Kosati, you can't get them anywhere. You would have to look at the video to get hold of the information. Any other questions? Okay, guys, if you do have any other queries, please post them on my Unisa. I do check in every day, so I will answer fairly promptly. And I emphasize again, please make sure you've got IRIS set up and access the IRIS specific mock exam and make sure that your installation works correctly. And if you have any issues or problems, please post them, and also look at the discussion forum, those links for the webinars for the online exams. I recommend that you do attend at least one of them and ask any questions about them. But just make sure you know how to connect up for your exam and how to use IRIS. You don't want to have any problems on exam day. Okay, guys, then that's it. We'll be back next week, same time, and then the week after that, Dr. Pilkington will have a session on the most recent past paper.